Hi, this is Christopher Boucher, and I'm going to do a hypothesis test with a t-distribution using the p-value method. Okay, I'll get started. Now this uses similar numbers to a prior video that I did using the rejection zone method. So I'll just go through this first part kind of fast, and then I want to highlight the p-value part. Okay, the average annual salary for a starting painter in the United States is $30,000. A sample of 16 new painters shows an average annual salary of $31,000 with a standard deviation of 300. Based on this data, our new painters are earning significantly more than expected. Perform a hypothesis test at a 5% level of significance. Okay, so a couple things here. Let's see, we know this is a t-distribution question because of a couple reasons. Of unknown sigma, and n is less than 30. So we're going to use the t-distribution. Therefore, okay. So our null hypothesis is the status quo, which is plumbers are making 30,000 or less. So that's mu is 30,000 or less. And the alternative hypothesis is they are making more. So I know that this is the null hypothesis, meaning mu is 30,000 or less, because because the last part of it said, based on this data, meaning the sample, are they making more? So our alternative hypothesis has to be the more part. Okay, so that's mu greater than 30,000. Okay, and mu is 30,000. And S, big S, which stands for the sample standard deviation. So we know that we have a sample standard deviation and not a population standard deviation because of this. So in the first sentence, they talk about the average, which is the mu, or the population mean, 30,000. Then it talks about a sample of 16 new painters, shows an average annual salary of 31,000, so that's our X bar, with a standard deviation of 300. So the standard deviation is mentioned in the same sentence as the sample mean. So we know that it is a sample standard deviation. Okay. If it was a population standard deviation, it would be up top with the population mean. Okay. So our big S is 300. And our X bar is 31. I'm going to run out of room, but it is 31,000. And our N is 16. Okay. I always draw pictures with the hypothesis tests. And the inequality of the alternative hypothesis always points towards our area of interest. So in this case, it's pointing to the right. Even though we're not using the rejection method, we still want to set this up like we are. We can call this our area of interest. It's still a rejection zone, but we're dealing with probabilities and p-values. Okay, so it's interesting with the t-distribution. There's not a lot to do at this point, and there's a couple reasons. I want to show you the t-distribution table. The t-distribution table is quite a bit different than the z-table in that we use the degrees of freedom, and we use the significance level to find the t-score. So in the z-table, we can use the z-score to find the probability under the curve. The t-table does not give us the probability under the curve. To do that, we have to do calculus or use a calculator. So in the past, that's why people would do the rejection zone method, because it was something that they could still do without calculus or the calculator. Now with calculators, it's really a lot easier. So let's go and lay this out and then use the calculator. So let's write out our critical rejection area of significance or value that we will use, where if our calculated value is less than the significance level, then we're going to reject. So it is 0.05 or 5% essentially. What that means is we're satisfied with the idea that if we get into this area and we have a calculated value less than 5%, then we're okay with the possibility that we might be wrong a little bit. Now, with that said, that's why you want to do these tests over and over to make sure that you're right. One hypothesis test is not gonna be the end all. Okay, so we have this laid out, and now let's go to our calculator. Okay, so we pull up our calculator, turn it on. We're going to go to Stat, and then we're going to go over 2 clicks, and we're going to go to t-test. Hit enter. Very similar to the z-test, except it's for the t distribution. So we don't want data, because data would be if we had a list of data. We're just going to be entering in the stats. So do enter, go down, and then our mu is 30,000, and our x bar is 31. Then our SX, they have SX, but it's the big S. It's our sample standard deviation of 300. And our N is 16. And this is where we put in the symbol that's used for the alternative hypothesis. And in this case, the alternative hypothesis is pointing to the right. So we're going to put in the one that's pointing to the right. And then we're going to calculate. So we get this kind of awful looking number in the scientific notation, but one thing you can take from that is this. So it gives us this very small number. This right here, the p-value. So like I said before, you can't really calculate this unless you're using calculus to get this p-value. So the calculator is very helpful. So this is, whenever you have the scientific notation like this, where it says E, like say -10, what you do is you move over whichever direction it is. This is -10. So we're gonna move this decimal place 10 spots, which means I'm gonna put 9 zeros in front of the 5. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, and then it's 5, 0, 5, we'll say. Okay? Very small number. That's the calculated p-value. So what this means is this number is so small, it would be way out here somewhere inside of our area, in the very infrequent area. I will minimize the calculator. And what that means is we are going to reject H0, which means starting painters may be making more than expected. And remember, with the p-value calculation with hypothesis testing, we do this. If the critical value if it is greater than the calculated value, calculated value is this one. It's what we calculated. The critical value is what we're given. If this is true, the critical value is larger than the calculated value, then we always reject H0. Okay, thank you for watching.